All right, welcome back. You've made it through one chapter. We're on actual chapter one of physical geography. And today we start by talking about the atmosphere. And just to give you a heads up, as you'll learn through the course of the semester, I don't have an office, so I'm at home, sitting at my desk, which is in the back half of our dining room. I have a 4-year-old and my wife here, so you're going to hear stuff in the background. Life is life. I'm assuming that all of you have that issue. So don't be alarmed. I'm not alone. But we start off with this idea of our atmosphere. It's all that separates us from space. Oftentimes I've heard the phrase a thin blue shell. If you look at this picture, that hazy blue line is actually what our atmosphere looks like from space. Very thin. In fact, it's so thin that if you were to compare the thickness of the atmosphere to the Earth, it's about the same as the thickness of an apple peel to an apple. So the book always kind of starts out with like this kind of case study example of something that we're going to be talking about. So when we talk about the atmosphere, one of the things that comes to mind is pollution. And in Wyoming, there is a lot of mining for natural gas. One of the things that happens with mining for natural gas, it takes a lot of energy. You need energy to drive the drill, you need energy to pump the gas to a truck to take it away by train. So you burn a lot of energy to power generators. So that's a lot of energy. Secondly, the machinery tends to be diesel, and diesel tends to burn a little more dirty than say other types of machines. So it puts a lot more pollution. And in fact, some parts, with the combined leaking from the mines, we see that some areas of Wyoming, which you think about Wyoming, this is where Yellowstone National Park is, right? Wide open skies. They actually have ground level ozone pollutions that are twice as bad as Los Angeles or Houston. Okay? So a couple other impacts about this. To extract this natural gas, we do see the ground level pollution, which we'll talk about. And there's also this suspected link between natural gas that is being mined and leaking into the ground, getting into groundwater. So if you ever want to do something for fun, go on YouTube and type in the search phrase, light my tap water on fire. Just for kicks. So what is the atmosphere? Well, we know it's air. But we can break it down into two things. And the first are what we call the permanent gases. And these are the gases that stay in the same amount of proportions pretty much all the time. Almost the entire atmosphere, 99%, is composed of oxygen and nitrogen. Okay? Now, that 1% that's left are called the variable gases. And these are small amounts that can fluctuate. So we're talking about things like carbon, hydrogen, argon, ozone, water vapor, which is a gas, and it can fluctuate. So here's just an example. Nitrogen and oxygen are the vast majority of our atmosphere. The rest, not even 1%. And when you look at the variability, carbon dioxide can vary very much. Okay? These are the carbon, by the way, these are the gases that act to create the greenhouse effect that we're going to talk about. I'm interested, most people don't realize that they're very, very small. Carbon is less than 3/100th% of the atmosphere. So gases can enter or leave the atmosphere. And so we think about this, the source, like a sink in your house. Water would enter through a source, the faucet, and leave through a sink. So the same thing applies with gases. Sinks can be physical environments or processes. And sources, natural or anthropogenic. So here's an example. Let's look at oxygen. Where does the oxygen in our air come from? It actually comes from photosynthesis, right? Plants breathe in carbon and exhale oxygen, the opposite of us, right? So carbon or oxygen enters through photosynthesis. Carbon dioxide. We hear about carbon as a byproduct of human effects, and it is. But the largest single source of carbon every year into the atmosphere comes from volcanic eruptions. So many different sources for different things. What are some sinks? Well, oxygen. One of the ways oxygen leaves is by weathering. If you've ever seen rust, rust is what happens when oxygen bonds with other materials like iron or steel. And that actually pulls the oxygen from the air and solidifies it. Carbon can be pulled from the air when plants breathe it in. Plants breathe in the carbon, they use it to build their cellular walls, and the carbon is stored that way. So I'm not going to go over all of these, but just know that there are many different ways. There's other things in the air as well that aren't gas. These are aerosols. Aerosols are just tiny little drops, either solid or liquid, that are so small they can float in the air. So a cloud, when you look up at a cloud, you're actually seeing tiny little drops of water. You're not seeing water vapor. When water is a gas, it is invisible. When you actually see a cloud, you are seeing millions and billions of tiny little drops of water. They are smaller than the tip of a pin. They're not a raindrop, they're even smaller. This could also be dust, smoke, many different things. If you've ever seen a dust storm, emissions when a factory burns and pollution comes out of the smokestack, bacteria. Uh, Most of us probably have some issue with pollen right now. I know I'm kind of stuffed up. I find this one interesting. Salt particles. If you go near the ocean, if you've ever been near the ocean, it kind of all smells salty. That's because as the water and the waves hit the shore, the salt in the water actually sometimes can get into the air. So, now that we know what is the air, let's talk about the weight of air, the pressure. So air does have weight because remember molecules of air, atoms of air, so hydrogen, oxygen, those are parts of matter. They're just very light, but they do have an actual weight or mass. And it's the combined mass of this with Earth's gravity that keeps the air on the planet. Gravity holds it down, just like it holds down the water. Okay? Now, as you go up in the air, 1 mile, 2 mile, 3 mile, 4 mile, the air gets thinner. There's less of it. We'll talk about that. But the atmosphere doesn't end. It doesn't like you go to 102 miles and that's it. It just gradually fades out. Most of the atmosphere is roughly in the first 20 miles. 99% of the mass of air is within the first 20 miles. The atmosphere, they usually say that once you hit 100 miles, then you're in space. But air pressure, this is what we call the molecules of air pushing against things. Now, we don't always notice it, except for when it changes. Maybe you felt the air pressure change, often called wind. But here's a good example. If you've ever been in a swimming pool, right, in the shallow end, you feel the water on you, but if you dive down deep to the bottom of the deep end, you can feel the pressure increasing. That's because here, there's more water on top of you, so there's more weight pushing down on you. There's less water pushing on you here, less pressure. And so that same thing applies in the atmosphere. Sea level is basically the lowest elevation we can go to that has air, which means that there's the most air above it. As you go up hills and mountains, there's less. So air pressure, generally speaking, is lower the higher you go. Here's just kind of an example. If you notice these little tiny dots, these represent molecules of air. There's more air at the surface. The higher up you go, the less dense the air is, therefore the less air pressure. There's less weight, there's less air above to push on it. Now, how do we measure this? Well, we actually have tools. We'll talk about those, the barometers, they call that. But roughly speaking, at sea level, it's about 14 pounds per square inch. So if you were at sea level and you just thought about your hand, for every square inch in your hand, it's being pushed at about 14 pounds. We don't notice that because the cells in our bodies have evolved in balance with this. They push outward at that rate. So we don't really notice it. We're kind of in balance. That's why if you go up into an airplane or up into a mountain when the air pressure drops, you'll notice it. Maybe you'll start to swell a little bit. You might have trouble with your ears, or sometimes people have trouble with their heart. Conversely, if you go down too deep into the water, the air pressure, once you go below water, then it's water pressure. And at a certain point, the pressure of the water is what it actually would crush you. So we kind of live in that special balance. All right. So we're going to pause right here for station identification. We'll be back with part 2 in just a moment.